Any aviator or aircraft designer will tell you that of all the things you can give an aircraft design, speed is one of the most expensive. Not only in terms of money, but also in the terms of sacrifice of other types of performance. For example, everybody's favorite fast jet, the SR-71, true rocket ship. But all it could carry was a camera, and it had to have a lot of air refuelings because it guzzled the gas. So its range without aerial refueling wasn't really all that far. But you compare it to the humble Cherokee, 105 knots, 300 to 400 mile range, 2.5 people. That's with probably foolish tanks, and at a pretty nice little price, affordable. The average guy can afford one. It's a well-balanced airplane for what it is. But let's say you're that pilot that wants to go a little bit faster and carry a little more weight. Well, that's going to come at a cost. You move up to the Archer, and you start realizing the airplane gets substantially more expensive, only to pick up about another 15 to 20 knots. And then you move up to the Arrow, which really doesn't add that much more in useful load, but wow, are you paying for that little bit of extra speed? The Arrows I used to fly usually did 130 to 135 knots in cruise, but they drank 12 gallons an hour to the humble little Cherokee's 6 or 7 gallons an hour if I leaned it right. And you start realizing that speed is expensive. We really didn't get much of an improvement in useful load or range. What we got was an improvement in speed. And we virtually doubled the price of purchase and operation to do it. And this doesn't just apply to general aviation aircraft. Military aircraft have the same problem. Airplanes that are made to go fast usually have to start carrying external fuel tanks to go far. Military interceptors were designed to go fast, 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 and they did. The job was so important that the governments decided it was worth the expense. But their payload was a radar and a couple of missiles. That was it. Almost everything was sacrificed for speed. If you wanted to carry a lot and go a long way, then of course speed had to be sacrificed. If you wanted to carry a reasonable load a long way very quickly, then you had to be part of an extremely expensive operation, an aircraft that was so expensive to operate that it never really did much more than a niche. In fact, in many ways, it was a little more than a national flag-waving project. Now, there are some efficient, fast airplanes out there, even with a respectable payload, but they came at the cost of being kind of uncomfortable inside because everything had to be around speed. The airplanes had to be small and they had to be powerful. The Aerostar is probably one of the best balanced airplanes in this regard, but it's a fairly demanding airplane to fly. It's also pretty expensive to keep operating. An airplane like the Aerostar really requires a proficient pilot, and it's pretty tight inside. One airplane that offers an excellent balance between speed, range, and payload is the Cirrus. But unfortunately, that airplane costs more than my house. No, I'm not being facetious. These airplanes can easily clip $1 million. You move up into the more complex singles like the A36 Bonanza. Again, costs more than my house. You're getting a performance bump. But ironically, in this airplane, the purchase cost isn't really that much worse. It's the operating cost that gets higher. But then I guess if you can afford an A36, you're not really sweating the operating cost. But as you move up the single engine chain, you get to the multi-millions of dollars with planes like the Pilatus. Now here's an airplane again. Fast, comfortable, good payload, long range. You're simply paying for all that with lots of money. In fact, one could argue that an airplane like the Pilatus is virtually as well balanced as the humble Cherokee. But of course, you're paying a lot for that speed. And if you can afford it, that's great. You start moving up into multi-engine turboprops, you get another speed bump, and of course you get multi-engine safety, but the cost goes up accordingly. As we move into the jets, the same thing applies. You can have speed, or you can have speed and range, or you can have speed, range, and payload, or you can go super fast with a big payload, but the prices go up exponentially as you do. With military aircraft, it's the same thing. You have the very economical F-16, which is a fast little airplane, maneuverable, great at its job. You can even move up into the supersonic bomber, but the cost of operating these things gets outrageous. The top shelf Mach 2 plus fighters are unbelievably expensive. When you move up to the SR-71, which of course has since been retired, largely due to the cost, you get to the point that even governments can't really afford to operate them anymore. The cost of speed goes up faster than anything else. Boom is working on a new supersonic aircraft that won't leave a sonic boom. You think about the amount of money that's been put into that. Perhaps at some point there'll be some fundamental shift in propulsion materials and aerodynamics that'll make supersonic speed available at a nominal cost to everybody, but I don't think we're going to live to see it. I guess the thing I'm saying is that you wind up with this magical triangle of payload, speed, and range, and in the middle they're all glued together by cost. And if you want to add something to an airplane, adding payload usually isn't that expensive. Adding range isn't usually that expensive. If you want to add 20% of speed, in many cases, you pretty much have to double the cost of operations and often the cost of purchase. In the 50s, the Canadians were working on the CF-105, which was one of the most beautiful airplanes ever conceived, and that thing was fast. They never even got the Iroquois engines into it that it was designed for. They were using some lower thrust engines they borrowed from the Americans, and it still did amazing stuff. Enough to the point that it kind of terrified the American aviation industry. In fact, a lot of the engineers wound up working for American companies after the program was canceled. The airplane is big because it needed a combination of speed and range and, of course, payload. It had all three. It would have been wonderful to have finished the test program to see what that plane was capable of. But the cost of getting all those things, especially the speed, was about to bankrupt the nation. Of course, in all fairness, the cost of the fire control system they wanted was just as bad, so you can't blame everything on the cost of the desire for speed. But that was the big engineering challenge for the airframe, and they met it. A lot of the really fast airplanes these days are home built, but of course they sacrifice payload and often range to get that speed. So basically, all I'm driving at is that of all the things that an airplane has built into its design, the thing you'll pay the most for is speed. Not only in dollars, but in other kinds of performance. Getting that balance down, on smaller aircraft, it's doable. On larger aircraft, well, if you ever build a 300-seat airliner that can go Mach 2 economically across the globe, you'd have the absolute world beater. We know. We've tried. I'm Max of Pilots and Prop Wash. Tell me what you think below. As always, guys, I hope it's smooth and cruise and you arrive at the gate 5 early.